Okay, here we're starting the chapter 20 and 21 homework with chapter 20, number 46. And here we've got a parallel plate capacitor made of two circular plates. And we're first asked to find the radius if the overall capacitance is 1 times 10 to the minus 6 farads. So I'll be using the equation, the capacitance equals epsilon 0 A divided by D. A lot of times you can put in that K, but for air we're going to approximate this as just 1 for the dielectric of air. So epsilon 0 is 8.85 times 10 to the minus 12, and the area would be pi times r squared, so it's a circle, and divided by the distance, which is 1.5 times 10 to the minus 3 meters, so we can set that equal to 1 times 10 to the minus 6 farads. From that, you get the radius is 7.3 meters. In part B, it asks, if the separation between the plates is increased, so D is increased, should the radius of the plates be increased or decreased to maintain the capacitance? Well, the distance, as this goes up, capacitance goes down. So area must be increased to maintain the capacitance. And so that means that the radius r must be increased to increase the area. Then for part C, find the radius of the plates that gives a capacitance of 1 microfarad with a plate separation of 3 millimeters. So for this, capacitance is 1 times 10 to the minus 6 farads. That equals epsilon 0 pi r squared divided by 3 times 10 to minus 3 meters. And so you have doubled this distance. So basically you're doubling the area, and with the pi r squared I get the radius to be 10.4 meters for the new radius. The next problem I wanted to look at actually comes out of chapter 21. And in chapter 21, problems 53 and 55 go together pretty well. And in 53, it asks you to find the equivalent capacitance of this segment. And this is a common kind of multiple choice problem. So you want to think about the most complicated section, so here, and those two are in series. And remember, capacitors in series will add 1 over the equivalent capacitance is 1 over C1 plus 1 over C2. So this side would be 1 over 8.3 microfarad plus 1 over 22 microfarad. A lot of times, just a hint, you could keep the micro in there and then just know that your answer will be in units of microfarads. And for this series section, we got that the equivalent capacitance of that part is 6 microfarad. And then you could look at the whole situation overall, where notice this would be 1 over 6, so this would kind of be the equivalent capacitance answer. And if this side is 6, or could be replaced with 6, and that's now in parallel with a 15, these two would add in parallel. And so the equivalent capacitance is C1 plus C2. And C1 plus C2 would be 15 plus 6. So the total is 21 microfarads for the total. And then in problem 55, they ask us to find the energy stored in each of these capacitors. And what I like to do is set up a chart And we could do our Q, C, V, and then we could even do a spot for the energy stored. Remember, the energy stored in the capacitor would be 1/2 QV. And let's see if we have our capacitors. We'd have the total of 21 microfarads, and then we'd have a 15 microfarad, and we'd have the 8.2 microfarad. Sorry, I don't think I could read my handwriting up there. This must be 8.2. And we have the 22 microfarad. For voltage, it says for this question, this is hooked to a 9-volt battery. So that means like across the ends here, it's hooked to 9 volts. So if that's going to be hooked to 9 volts, which of the total voltage would be 9 volts, and then which of these capacitors would get all the 9 volts to themselves? The one that gets it all is the 15. So this would be 9 volts. Once you have any 2 out of the 3, we can use Q equals C times V to find the charge, and I got 189 microcoulombs and 135 microcoulomb for those charges. Then remember that the ones in series will have the same charge, so I know that these two will be the same, just as these two were the same, but that their voltage will be shared, that their voltage will add up in total to 9. And in order to figure out what charge these have, we have to think about, you started with 189 minus 135 that went on the branch with the 15, so what has to be left over is 54 microcoulombs. Once you do those charges with this capacitance, again, use Q equals C times V, and you get these voltage to be 6.6 and 2.5 volts. Then to find the energy, we just go through and solve 1/2 Q times V. And I got 8.5 times 10 to the minus 4 joules, 6.1 times 10 to the minus 4 joules, 1.78 times 10 to the minus 4 joules, and 6.75 times 10 to the minus 5 joules. And that's it for that one. And the last question I wanted to look at was problem 58. And here you're trying to find equivalent capacitance, but you've got this unknown capacitor in the middle. You know that this total section has an equivalent capacitance of 9.22 microfarads. So let's think about first, these guys are in series. They look kind of funny, but I know they're in series because an electron that went down this branch only has that branch to go through, and these have to have the same charge. So it would be 1/12 plus 1/8.35 equals 1/C, equivalent for this section. And from that, I was able to find that this would have an equivalent capacitance of 4.9 microfarads. Then that 4.9, if we think of that as being here, would be parallel to the 4.25. So this section, which is in parallel, would equal 4.25 plus 4.9. And that would be 9.17 microfarads. There we go. And now this parallel section is in series with C, so 1/C plus 1/9.17 equals 1/the equivalent capacitance for that section. And these guys would then be in parallel with the 7.22. So if I took 9.22 minus 7.22, I know that this equivalent needs to be 2. And if I put that in there, I get that the capacitance C is 2.56 microfarads.